So we have to understand what is a director circle. Okay, now try to understand what is director circle. So it is locus of a point, locus of a point where two perpendicular tangents can be drawn. Okay, so can be drawn to a circle. Right now we guys are studying circle, so we are using the word circle. Later you will be having parabola, ellipse, hyperbola, whatever it may be, but the definition of director circle will remain the same. Means it is the collection of all the points. Locus is collection, locus is collection of all the points from where you can drop two tangents, and both tangents should be perpendicular. So this is the unique part of this circle, director circle. Okay, now look at this. Suppose that we have this circle. You know center, you already know radius. Now look at this. I'll go with tangents. You know that the tangent should be perpendicular. Okay, so suppose this is the first tangent and suppose this is the next tangent. Okay, now you know that from outside point you can drop down two tangents, but this tangent is unique. This time both tangents are perpendicular. Now look at this. Can I connect this thing with origin so it will become perpendicular? Can I connect this thing with the chord of, means point of contact? I want to connect with the center, so it will become 90°. Okay, now look at this. Can I say that if I will connect the outside point with the center, you know that this thing is equal to this thing because both are radius. You know that this thing will be equal to this thing because the tangent drawn from the external point will be equal, and you know it is common. Okay, so side by side property, these two triangles are congruent. So can I say that the angle between the side 2 dash and 3 dash will be the equal? So these two angles are equal, so it is what? 45°, 45°. Earlier it was 90° na. So now half of it will become 45. Now you know that it is 45, you know it is 90°. So don't you think it will become 45°? Correct? So can I say that we guys are handling isosceles right angle triangle? Correct na? Now look at this. So like, you know it is radius, you know this is also radius because side opposite to equal angles are equal, so both are equal. Now we are interested in finding this length. Okay, because you know that the center will remain the same. Correct? Suppose it is O, A, B, like I'll assume this point as P and this point as O. Okay, so for center suppose it is x comma y or x1 comma y1. Okay, this would be much more better idea. So, take center as x1 y1. So can I write like center would remain the same? Because look at this, I'll tell you why. We will have same center. Now look at this. Suppose that you want to draw a circle, okay, and look at this. So from here, like suppose from here we guys are getting equal tangents to 100% we will get equal. Okay, we are interested in finding the points where tangent should be perpendicular to each other. Okay, so both circle will have same center. Okay, means the director circle and the normal circle will be concentric. Okay, so can I write x1 x minus x1 whole square plus y minus y1 whole square. Now we are interested in finding radius because radius will change, no? So what is the radius? So look at this. Can I write, you know that it is right angle triangle, so this OP will become hypotenuse. So can I write OP square will be equal to AP square plus AO square, and you know that AP and OP are same thing. So can I write R square 2R square. So OP will be what? R times root 2, and OP will become the radius. Okay, so can I say that the radius, like here radius we got root 2R, so it is root 2R whole square. So this is the equation of director circle. Okay, so it is root 2R. Center will remain the same, radius will become root 2 times the previous circle. Is that clear? Idea is clear, no?